Have you ever gazed up at the night sky, filled with wonder about the vastness of the universe? The twinkling stars, the infinite expanse, it all seems so real, so tangible. But what if I told you that this reality, the one we experience every day, might not be as concrete as we think? What if everything we see, feel, and experience is not what it seems? Imagine walking through a misty forest at dawn, where the fog blurs the lines between what's real and what's imagined. This could be a metaphor for our own reality. What if our reality is merely a projection, a holographic image of something far more profound and complex? Just like the reflections on a calm lake, what we perceive might only be a surface-level representation of a deeper truth. The idea that our universe might be a hologram may sound like something straight out of science fiction, but it's a serious scientific theory that has been gaining traction in recent years. Imagine a cityscape at night, with its myriad lights and structures, all potentially being a sophisticated projection. The holographic universe theory challenges our conventional understanding of reality and proposes a mind-boggling concept. The information about our three-dimensional universe could be encoded on a two-dimensional surface. Think of a microchip, where vast amounts of data are stored in a tiny space, or a spiderweb, intricate and delicate, yet incredibly strong. This theory, though still in its infancy, has the potential to revolutionize our understanding of the cosmos and our place within it. Just as the sunrise brings new light to the world, this idea could illuminate the mysteries of the universe. The waves crashing on a rocky shore remind us of the constant ebb and flow of knowledge and discovery. It forces us to question the very nature of existence and grapple with the possibility that what we perceive as real is but a projection of a deeper, more fundamental reality. Picture someone deep in thought while walking in nature, or meditating on a hilltop, contemplating the essence of their being and the universe around them. As we delve deeper into the holographic universe theory, we'll explore its origins, its implications, and the evidence that supports it. From ancient ruins that hint at lost knowledge to modern scientists peering through telescopes, seeking answers in the stars, the quest for understanding is timeless. Prepare to embark on a journey that will challenge your perceptions and expand your understanding of the universe and everything in it. Imagine walking on a long, winding road with a dramatic landscape stretching out before you, symbolizing the path of discovery and the vast horizons of knowledge that await. To grasp the essence of the holographic universe theory, we need to start with a fundamental concept: information. Information is not just data stored in computers or written in books. It is a more profound and universal concept that underpins the very fabric of reality itself. In the past, physicists primarily focused on matter and energy as the building blocks of reality. They studied particles, waves, and the forces that govern their interactions, seeking to understand the universe's most basic components. However, in recent decades, information has emerged as a crucial component in understanding the universe. This shift in focus has led to groundbreaking theories and discoveries that challenge our traditional views of reality. Think of information as the fundamental stuff that defines the properties of everything around us. It is the invisible code that shapes the structure and behavior of matter and energy. It's the code that differentiates a hydrogen atom from an oxygen atom, determining their unique characteristics and interactions. A grain of sand from a distant star. This information is encoded in the very fabric of space and time, influencing everything from the smallest particles to the largest cosmic structures. Every object, every interaction, every process in the universe can be thought of as a manifestation of information. This perspective allows us to see the universe as a vast, interconnected web of information, where every part is linked to every other part. This shift in perspective, recognizing information as a fundamental aspect of reality, paves the way for the holographic principle. This principle is a radical departure from our conventional understanding of space and matter. This principle, in its simplest form, suggests that the information content of a region of space is proportional to its surface area, not its volume. This idea has profound implications for our understanding of the universe's structure and behavior. Imagine a box filled with objects. You might assume that the amount of information within the box depends on its volume, how much space it occupies. The holographic principle challenges this notion, proposing instead that the information about the objects inside is actually contained on the surface of the box, like a complex coded pattern. This means that the surface area of the box holds all the information needed to describe its contents. This concept may seem counterintuitive at first, but it has profound implications for our understanding of the universe, as we'll see in the following sections. It suggests that the universe operates in a way that is fundamentally different from our everyday experiences. This principle has been supported by various theoretical and experimental findings, leading scientists to reconsider the nature of space, time, and reality itself. It opens up new possibilities for understanding the cosmos and our place within it. It suggests that the universe, at its most fundamental level, might be a projection of information encoded on a distant, two-dimensional surface. This idea challenges our perceptions and invites us to explore the deeper, hidden layers of reality. The holographic principle, in essence, proposes a remarkable idea. The information about a three-dimensional region of space can be completely encoded on its two-dimensional boundary. This concept, while seemingly abstract, has profound implications for our understanding of the universe and the nature of reality itself. It suggests that the three-dimensional world we experience might be a projection of information stored on a distant, two-dimensional surface. Imagine a hologram, a two-dimensional image that appears three-dimensional when viewed under the right conditions. Holograms are fascinating because they challenge our perception of depth and space. They are created by recording the light scattered from an object and then presenting it in such a way that it appears to be three-dimensional. This analogy helps us grasp the essence of the holographic principle. The holographic principle suggests that our universe might operate in a similar way. Just as a hologram encodes three-dimensional information on a two-dimensional surface, the universe might encode its three-dimensional information on a two-dimensional boundary. This idea is not just a theoretical curiosity. It has significant implications for our understanding of space, time, and the fundamental nature of reality. This principle challenges our intuitive understanding of reality. We are accustomed to thinking of the universe as a vast expanse of three-dimensional space filled with stars, galaxies, and other celestial objects. However, the holographic principle suggests that this three-dimensional space might be an emergent phenomenon arising from more fundamental, lower-dimensional processes. We perceive the universe as having three spatial dimensions: length, width, and height. These dimensions define the space in which we live and move. They are the framework within which we understand physical objects and their interactions. But what if this perception is merely a projection of information stored on a distant, two-dimensional surface, just like the hologram? But what if this perception is merely a projection of information stored on a distant, two-dimensional surface, just like the hologram? This idea might seem far-fetched initially, but it emerges from theoretical work in black hole physics and string theory. These fields of study have revealed surprising connections between information, gravity, and the fabric of space-time. This idea might seem far-fetched initially, but it emerges from theoretical work in black hole physics and string theory. Physicists studying black holes discovered that the information content of a black hole seemed to be proportional to its event horizon's surface area, not its volume. This was a surprising and counterintuitive finding, but it led to the development of the holographic principle. Physicists studying black holes discovered that the information content of a black hole seemed to be proportional to its event horizon's surface area, not its volume. This realization led to the development of the holographic principle, suggesting that this principle might apply to the universe. If the information content of a black hole is encoded on its two-dimensional surface, could the same be true for the entire universe? This realization led to the development of the holographic principle, suggesting that this principle might apply to the universe. The idea that the universe's information could be encoded on a two-dimensional surface challenges our conventional understanding of space and time. It opens up new avenues of research and exploration, pushing the boundaries of what we know about the cosmos. The holographic principle doesn't imply that our universe is a literal hologram. Instead, it's a metaphor that helps us understand the relationship between information, gravity, and the fabric of space-time. It's more accurate to envision it as a deep principle of nature that governs the relationship between information, gravity, and the fabric of space-time. It's more accurate to envision it as a deep principle of nature that governs the relationship between information, gravity, and the fabric of space-time. This principle suggests that our understanding of the universe based solely on three spatial dimensions might be incomplete, and that a more fundamental description might exist on a lower dimensional surface. It suggests that our understanding of the universe based solely on three spatial dimensions might be incomplete, and that a more fundamental description might exist on a lower dimensional surface. This profound shift in perspective opens up a realm of fascinating possibilities and challenges us to reconsider the nature of reality itself. It invites us to explore new ways of thinking about the universe and our place within it. This profound shift in perspective opens up a realm of fascinating possibilities and challenges us to reconsider the nature of reality itself. As we delve deeper into the mysteries of the universe, the holographic principle serves as a reminder that our current understanding is just the beginning. There is still so much more to discover, and each new insight brings us closer to unraveling the true nature of the cosmos.